In this video, we evaluate an integral using division and partial fraction decomposition on the way. So we have the integral of x cubed plus 3x plus 2 minus 2 divided by x squared minus x dx. First, we do long division because the degree of the numerator is greater than the degree of the denominator. Each time the degree of the numerator is higher than or equal to the degree of the denominator, we do division first until we get a remainder with degree less than that of the denominator. So the division is as follows. So we divide x cubed plus 0x squared plus 3x minus 1 by x squared minus 1. See that I added 0x squared here because we do not have x squared term in there on the numerator. Therefore, we need to replace it with 0x squared. So first, take x cubed, divide it by x squared. That gives you x. Now multiply every term here by x. So we get x squared times x is x cubed. X times negative x is negative x squared. Now you flip the signs and get negative here and plus there. So adding, you get 0. Adding, you get x squared. Now bring the 3x down, bring the negative 2 down. Do the same thing now. Now we are dividing x squared minus plus 3x minus 2 by x squared minus x. So divide x squared by x squared, you get 1. So multiply everybody here by 1, and we get x squared minus x. Now flip the sign again. The x squared cancels out, and then you have 3x plus x is 4x, and then bring the negative 2 down, you get negative 2. Now realize that the degree of 4x minus 1 minus 2 is less than the degree of x squared minus x. Therefore, we stop the division here, and this is our remainder. So the integrand is equal to the quotient, which is x plus 1, remainder divided by the divisor, which is x squared minus 1. Now, the next thing is to factor the denominator here and then use partial fraction for this expression. And that gives us the following: x plus 1 plus 4x minus 2 divided by x factor to x minus 1. And then since we have x as one factor and x minus 1 as another factor, we have two partial fractions, and one with denominator x, another one with denominator x minus 1. So we use a over x, b over x minus 1. So to find a and b, we need to reduce this to common denominator, which is common denominator, that is x minus 1, and simplify to get the following. And we get a plus bx minus a divided by x factor to x minus 1. Now we have to match the coefficient of x and the constant term. So coefficient of x in this one, we have a plus b, and here is 4. So a plus b is 4, and the constant term negative a, negative 2. That means a is 2. Negative a is negative 2. Therefore, a is 2. And solving, we get b also 2. Therefore, we have the following. The integrand can be written as x plus 1 plus 2 over x plus 2 over x minus 1. Therefore, the given integral can be written as integral of x plus 1 dx plus integral 2 times integral of 1 over x dx plus 2 times integral of 1 over x minus 1 dx. And each of them, the integral is easy to perform. Therefore, the integral of x squared, x plus 1 is 1 x over 2 plus x, and the integral of 1 over x is ln of absolute value of x. The integral of 1 over x minus 1 is ln of absolute value of x minus 1. Then don't forget the constant term. Using the property of logarithm, we can simplify these two terms, and that gives us the following. We have 1 over 2 x squared plus x plus ln of x squared factor to x minus 1 squared, all that plus constant.